Hi everyone, and welcome back to the Cockpit project, part 23 already. Okay, this one, if you remember the last video, we did 3 large buttons which give me kind of some fairly essential functions that I needed from within the Oculus. Now, this particular panel I'm already spot drilling out here is going to hold an array of 15 buttons. So we're going in with some spot drilling, and you can see there's a problem there because my bed is not level and some of the spot drills have not been cut out. So basically I reran the routine but altered the zero down 1 or half a millimetre so that it properly cut them, and then we come in with a 6.5mm twist drill. So anyway, this is going to be a panel, whilst that's drilling out, that's going to hold 15 buttons on the left hand side, and it's going to kind of slope up from where the 3 large buttons were up to the kind of frame on the tabletop. Now, I'm not quite sure what functions I'm going to assign to those buttons yet, but they'll be quite handy, whether the cockpit's essentially configured for Elite Dangerous or perhaps a race setup in the future when I put a wheel back on there and a set of pedals. Various other perhaps flight sims, War Thunder perhaps, DCS is another one that I'm perhaps looking at getting into, and perhaps others, who knows. So plenty of options, and they're all programmable. They'll all be going into the Leo Bodnar board as normal. That gives you 36, I think it is, button inputs, 4 of which I think are 4-way hat, and then just ordinary buttons for the other 32. The board also gives you 8 analogs inputs or axes that you can use, so it's quite fully featured, and takes certain hall sensors where they've got kind of an op amp already built into them, so they act like just like resistors. You can plug those straight onto the analog axes and have those work. Anyway, so this bit we're doing some countersinking. That's just a spiral and seems to be clearing the aluminium from that pocket quite easily. I think that's just a 2D pocket rather than adaptive or anything like that. It's probably not worth running adaptive because you have to do so much fiddling about trying to constrain it to the countersinks rather than cutting the whole object. It's not really worth the time. Using the old tried and trusted technique you've probably seen me use many times before, 3 flute serrated roughing end mill, and we'll spiral that in, and then we'll start to adaptively clear essentially a gutter right the way around the part, rather than using slot milling. And I'll say it again, I've said it many times before, I hate slot milling. It really trashes your tools and the machine, and this is just as quick really, because I'm getting a full depth of cut, 5mm right the way through the plate here, and it just needs a quick clean up afterwards, which is what this particular tool is going to do. And that's just a single flute end mill rather than a rougher, and that just whizzes off. You don't know if you can see on the back wall of that cut at the top there, you can see all the scallops that the roughing pass previously left, and this will just take those off. Okay, now that's done. The last toolpath I think we got to run on here is just a quick chamfer round the top edge, just to knock the sharp edge off of that. I think it's about a 1mm chamfer I use on this. Might have even been half, I can't remember now. Right, all done. Let's just get this out of here. All ready for switches and wiring. Okay, so that's the milling side of things sorted out, and now we go through the tedious effort of wiring all those switches up. They're all momentary switches, no latches on them. So they just act like a keyboard key press, I guess. For most of this kind of wiring, I'm just using Cat 5. The braided type, you can get solid core stuff as well, but this is braided, which means that it will tolerate a bit of vibration and movement. Anyway, once we finish that, we actually start 3D printing the mount for it, and I'm not sure whether oh yes, I have done 3D printing on the Cockpit, of course I have, with the armrest, but this is a two-piece mount to mount the plate in the Cockpit, and I took a long time to print these, probably about 36 hours, something like that. The second piece. Right, and then it's just a case of assembling everything. So after sticking the mount together, it's just a case of then mounting that onto the frame. Everything, because it's all CNC, fit pretty much perfectly. And all the screw holes and bolt holes are in the right place. So okay, we've got two new panels, and that's pretty much the front left side of the Cockpit finished. Got 3 buttons here, and good thing about these large buttons is that when I've got the VR headset on, I can actually see them out of the bottom. There's a gap at the bottom of the Oculus Rift. I can see those. This one I use for recentering the Oculus Rift, which is useful because it does occasionally drift off. This one here is for cargo scoop, and this one here is actually when I'm driving the SRV or the buggy on a planet, then I can hop in and out of the turret view that you've got there. Now I've got this grid of 15 buttons here, all nicely coloured. Not sure what functions I'm going to assign to these yet, so what I'll do is I'll just probably assign stuff as I play and think, oh, that'd be quite handy, and just assign them as I go along. So they're kind of spare, if you like, at the moment. You can't see on the side here, there's a sideboard because of the mount I've made for this, which is great. So it started filling in some of the panels, the gaps rather in the panels, and then I have the same on the other side of the Cockpit as well, which will be the next video, because that's going to get a glass Cockpit makeover using an Android tablet. But we'll come to that in the next video, so thanks for watching this one, and I'll see you in the next one. So here we are in Fusion 360, and as ever we're going to start with a sketch, but I think what I'm going to do in these videos now is, rather than talk through every little detail of making the models that I make, I'll rattle through it at a fair pace, and then to perhaps talk about a specific function or feature that we'll highlight for this particular video. So let's get underway with this one. So what we needed was essentially a bracket to mount the plate that I'm going to cut out for the switches, so on the left hand side of the cockpit. So if you can imagine, my knees are going to be kind of in this area here, and this is going to be the side, if you like, of the plate. And then what we'll do is we'll extrude this shape here out for the plate to mount on, so we can see that straight away. So just extrude this base piece out here, which should provide a nice stiff platform essentially to A, bolt onto the extrusion, and B, form a place where we can then extrude, what do we want to call them, arms I guess, out so that we can support the plate. So we'll do that next, and there's the first one. So I could probably get away with actually screwing and mounting the plate onto this just L-shaped piece here, but I figured we need another one, so we then extrude some more, which we just extruded all the way across. Now that's going to be obviously extremely wasteful if I print that, plus I wouldn't be able to get my switches on it because they would conflict at the back of the plate with that. So what we do is we cut out this piece here, then I've combined that into one body, and then it's really a case of drawing more sketches to put various details in. So we don't want this protruding up above the plate because that's going to be on a slope from kind of this point here down to here, and we only need this small arm. We don't want it protruding out past the edge of the plate, so we use essentially an extrude to cut away. He says, not seeing where that is. Now what I did is cut away but preserved the original body just in case I wanted to use it again, and then we cut away that piece so that we've got just this amount here, and then I think I had to extrude again to cut this piece away off the top, and then I was left with this little piece here, so I had to make another sketch look and then just extrude cut that off of the model altogether. So that's how we did all that, because we do another extrude and we use that circle there just to put the mounting hole in, and I think we also did this one here and this one here, probably one at the top there. Yeah, so those are all the mounting holes. We put a piece of filleting in just to round over the edges here. One thing I've found with both CNC and 3D printing, because it tends to be fairly precise, you get nice sharp edges, and you don't really want sharp edges all over the place. So then we've also extruded the side plate here just to fill in and give us a wall, if you like, on the inside of the cockpit. That's where my knee will probably rest up against when I'm in it. And then because I needed another extra piece, we extruded this little piece here just to give us the full width, if you like, of the plate that's going to sit on there. Did another combine just to make sure that's part of the overall geometry. And we're kind of getting to our mount here now. So really it's a case then of putting more sketches on, and I decided, well, actually what I can do is stabilize this even further by extending this plate out here, and there's actually an extrusion that will sit behind this, and I can put a couple of holes in, and that will allow me to essentially screw that into the side as well of the cockpit, making it even more rigid. And then a couple more of extrude for the holes, and then that's done. Then we've got a couple of holes, if you see this sketch on the bottom here. Extrude those holes there, which will mount onto the frame on the kind of side pod. And then we used an offset plane here. Now this is where we get to the bit where we're printing. Now this, obviously I can't print this shape no matter which orientation I put it in. I'm not going to be able to print this shape on the printer. It probably wouldn't fit anyway on my 3D printer, but also you've got massive overhang. So if I started off on this edge here, for example, and tried to print it upwards in this direction, it wouldn't be able to print this arm here. Similarly, if I printed it on this plane here, it would get all the way to the top and then wouldn't be able to print this piece here as well. So there aren't really any options other than what we're going to do is we put a plane in, so that's the construct and offset plane here, and I selected this face here and then didn't actually specify an offset, so it's an offset 0, which then puts a plane in there. And then what you can do is you can go to modify, split body, and then select the body you want to split, and then select the tool you want to use to split it with. And you see what it's done is extended that construction plane out so that it encompasses the whole model, the full extent of the model, and it's basically going to split it down on this plane here. So what we'll end up with is two bodies. So let me just turn some of this stuff off, and that's that operation there. And what we've got now is we've got this section here which we can then print up from this base here, and then we've got another one here that we can pretty much do the same thing on, so we can start printing with this as the bottom of the part and then print up. Okay, so then it was a case of, well, okay, I've got to attach these two. Now I could just super glue them together. That's not really a very good solution in this case, because this joint here is going to be suspended in midair. So what I did is start putting some sketches in, there we go, on the end here, and then basically put some holes through, right the way through this piece here into the larger body, and made most of this a countersink, so that what we'll actually do is we will have a bolt which will start about here and go into this piece here, or two of them actually, and then you can bolt the two together. And then in order to aid us in terms of locating it, to make sure it's all, you know, flush as it were, I then also did a sketch on this piece here. See, we got some holes in there, but also basically put some lugs and holes, so some locating or registration in. And if we just extrude those, we should see, there we are, there they are, there's the lugs there, and we should have corresponding holes in the other side there. So essentially that can locate in, and then the bolts will come through these holes, and we can thread the other side, thread this side. Let me just turn that off. So we'll thread that hole there and that hole there, and then essentially that will pull the two bits together and clamp them together. I can still glue them if I want to, and then just to aid in getting them in there, I'll just put a fillet on the top of the lugs, locating registration. And then all I needed to do was I checked to see where my holes for the switches were, and then realised I got too much in this area, so basically did a last extrude and sketch just to move this edge down a piece so that we could fit the switches in. So that's essentially our support mount. And of course what we'll also do is we can then do a mirror operation for this and fit it on the other side, but the other side's going to have something a little bit different, and I'll come to that in a different video. So all we then needed to do was click on make and click on one of the models, and I've got my print utility set to custom, and you point it to the Cura application, which is what I use for slicing. Click on that, and you can see Cura loading just off the capture screen here, and I'll bring it on in a second. I'll just bring that in so you can see it. And there we are, it's already put it in the right orientation. Doesn't always, sometimes you have to click on it and use this 3-axis rotation tool to fit it on the bed, but this was fine. So I just need to make sure that my parameters for infill were okay, and print speed, and this will take a long time, and this is 1 day 8 hours look, so I think I actually upped that to 80 millimeters per second on the print speed, which is fine for a big lump like this, and you don't see most of this in the cockpit anyway, so it doesn't have to be too pretty. And that's shaved another 7 hours off the print time there. You can also look at the layers, which is not such a nice view, but what it does mean is you can see where your honeycomb is as it does the infill. This plate here is going to be solid. So that's how we've made the support and did the printing. I'm not, as I said before, I'm not going to do the CAD for the plate, because the plate was essentially some all it was is a drilling operation, and using trachoidal cutout technique you've probably seen in dozens of other videos that I've got on the site. So I won't show that one, and